So today, let's talk about what a segment is. I know we did some of this yesterday, but I want to just discuss it to make sure. A segment is a type of line. So I'm not going to go through the full formal definition. If you didn't get it, you can check the notes yesterday, watch the video, or go on your book and check the definition. But it is a type of line. In other words, you know, out of the three, this is the one that most people think of, right? It's called a line segment. That's the formal name of it. The book will interchange. It might just call it a segment. It might call it a line segment. Sometimes somebody thrown off by that. But a line segment is a type of line. So it's the distance between 2 points, but then it has 2 endpoints. So there's a definite start and stop to a segment. So, give you an example here. That's a segment. That was basically the same drawing I gave you yesterday. Has a definite start and stop. It's measurable. We could put a ruler on the board and actually measure how long it is, because it definitely started and stopped somewhere. Now, the notation. So if the book says, name a segment that contains points A and B. Perfect. So what's the notation? How would you answer a question for a segment? What do you remember from yesterday? There's 2 ways to write it. Please.
Just AB.
Just AB. Okay, perfect. Just write it like that. AB. Don't even need the bar.
And then AB with the bar.
AB with the bar. Or AB with the bar above it. Now, you could switch the letters around, BA, or whatever you want to do. They mean the same thing. Now, the difference was, we explained yesterday, in case you were gone, was that why do they have 2 different ways of doing it? Is because this one right here, when they leave the bar off of it, they're usually, what they'll probably do in the next line or two, is they're describing the distance that's involved, how long it is. That's why they leave the bar off. If they put the bar on it, like this one, they're usually talking about the picture itself, like the drawing of it. So that's kind of the difference. They mean the same thing. So if you forget the bar, it's not a big deal. Now, the one thing we didn't get to discuss yesterday was segments themselves. They have definite start and stop. I always say that you want to use the endpoints. That's just the letters I want you to use. In a line, so if I were to draw a normal line that has arrows on it. C, D, E, and F. Okay, on a normal line, so they have arrows, right? That's a line. There's a clear difference. One's measurable. My segment up here is measurable, but the line over there, the right one, is not. But do you notice that in that picture there is segments? There's little pieces. You can actually take segments out of a line. So you could say CE with a bar above it. That's just talking about this distance right here, start to stop. No arrows going past it. Even though that is a line, you can take segments out of it. You're always allowed to do that. When you write lines, remember it's 2 letters with arrows above it. You can pick any 2 letters you want. So there is a definite difference between this and this. There's a difference. If you forget the arrows, you're talking about the stick that starts and stops at C to E. If you put the arrows, it means you're using the whole line. So if I were to add arrows to this, these 2 mean the same thing to me. If you put arrows in them. It's just different names for the same object. You're talking about the whole line now, when you put arrows on. So, makes sense why we have the difference? The difference between them? It's just a little thing of mine. I'm kind of very, very particular on what you write. So if you forget arrows, you're talking about something very, very different. And be careful when the book starts asking, name a line, name a segment, name an array. That's the next one we're going into. You have to be very specific on how you write your answer, because it either has to be like this, or you better put arrows or an arrow if it's an array. So we'll talk about that here in a second. Okay, I'll come back to this picture over here. I'm going to come back to this because we can draw arrays with that as well. Even though it's a line, you can draw arrays off of it. Alright. This red is terrible. I can't get off the board. Okay. Let's talk about array. Array is the other type of line we discussed yesterday. It is a type of line. Now, what was the difference between a segment and an array, please?
It has an endpoint.
Okay, it has one endpoint, right? One. So rays have one endpoint and then an arrow that goes a certain direction. Kind of looks like a vector if you're in science classes. But rays, they don't have distance. In physics, they would. They would have a magnitude. But this will keep going. It's non-measurable in math class. Okay, so if it keeps going, the ray is still a line, so it has to have a minimum of 2 points on it. So what letters did I leave with? G and H. Now, the notation. How would you write the name of it? That's the interesting part. How would I name this? Please.
You would do HG and put a dot over the H and an arrow going towards the G.
Boom. Love it. This is great. He was super specific the way he said it. HG, common sense, right? 2 letters. Even though if there's more, he picked 2. But he said the dot had to be above H. Wherever the end point is, that better be the end point when you write the name of it. And the arrow goes towards the other letter. That was perfect the way you said it. Now, if we switched it around and you wrote GH,
Put the arrow going the other way.
yeah, the arrow has to go the other way. Because if you go back to the same explanation we just said a little bit ago, the dot has to be above H, the arrow has to go towards the letter it was passing through, because the endpoint was H. Super specific. That was really good that you guys were remembering it, because that's tough for a lot of people. They're like, I don't understand the difference. The endpoint has to be labeled correctly. The arrow's passing through the other dot, or the other point down the road. Now, they're non-measurable. Now, here's the weird thing. You can compare rays. Some rays are longer than others because of where they start. Like, for instance, EF, where I go E to F, that's a ray. Even though that is a line, I could say the ray from E to F going this way. That technically, even though it's infinite in length, it is shorter than D to F. Just a hair bit shorter. I know that's like weird thinking about that. That if it's infinite in length, how can you compare them? It is. You can see there's a definite start and stop. One's longer than the other, just by a little bit. There's a difference. Even though they're non-measurable, there's still a difference between them. Okay, questions on rays and how you can name them. Rays will come up more important in the later sections when we start talking about angles. So I know right now it seems kind of pointless. We have lines, we have segments, but rays are huge later on. They are. Okay, today we need to talk about a couple different things. We got to talk about the word congruent one more time. We introduced that word yesterday. We had a new symbol for it. It's big. I didn't get to all of it. I just kind of gave you the brief introduction to it yesterday. I gave you the basic definition. We're going to get to segment addition today, where you can add sticks together. That's kind of important. We'll talk about that. We'll do some algebra, so hopefully this will refresh your Algebra 1 skills if you have some. And then we're going to talk about measurement today, how to measure objects. Okay? And that's going to be the part we'll probably end with today. So it's pretty straightforward. We're going to do a little bit of hands-on when we get to that part. So it'll be a little more interactive with that. Okay? All right. So let's talk about the word congruent here. Let's go back to segments. I'm going to leave that one segment on the board. Leave those drawings. Okay. The word congruent. Now, most people know it means equal. You're equal if you're congruent to something. But it's more specific. It's congruent, or it's equal, in size, shape, and measure. 3 things: size, shape, measure. You can have a little model car. I think I used that example yesterday. Yeah, my car looks like a spaceship. Let's go with it. Here's my little car. You can have a little model car being the same shape as the big car. Here's my big car, the real car. Okay, they can be the same shape, but you can definitely see that the size is off, the proportionality of it. Proportions are different. Okay, this one's huge, this one's, there's a scale model of it. For it to be perfectly congruent, they have to be the exact same dimensions, same size, proportions, 1-to-1 proportionality. So it has to be lifelike. So 1-to-1. The shape has to be the overall the same, well, they're both cars, fine. And then the measure has to be the same. So everything about them, down to the smallest detail, has to be exactly equal. So for things to be congruent, you have to have the overall same geometric shape, the proportions have to be the same, and the measurements have to be identical. This is the symbol we use in geometry class. It's an equal sign with a little squiggly above it. We talked about that yesterday. And that's the congruent symbol. We only use that symbol when you're describing shapes. Certain things are equal to each other. They're congruent to each other. So if I were to draw two segments on the board, let's call this one X and Y. Now, if they gave you the numbers on the board, where this is 1 foot long, and this is 1 foot, like they actually told you they're the same length. They're the same object for both segments, they both have the same length, they're congruent to each other. Because they're everything about the size, shape, and measure are all the same. So you could actually say the segment A to B is congruent to XY, that segment. We use a congruency symbol to talk about shapes. If you use an equal sign, that's for algebra 1. 2x plus 1 equals 5. There's a difference between using equal signs in algebra versus geometry's congruency symbols. Talk about shapes themselves. Now, what happens if I didn't have the 1 foot marker here? Would we know that these are necessarily congruent to each other? No. You'd have to take out a ruler, measure them, some form of tape device that you can actually figure out the distance there and see if they actually work. There is a symbol that the book will start using from now on that signals whether these two shapes have the same length even though you don't have a measure for them. And it's this little symbol. They're going to put a little dash on each stick. That dash means that they're the same length. It could be anywhere on a picture. It could be this crazy looking, octagon where there's 8 walls to this thing, like a stop sign, where they're all different sizes, where this is 12 inches, and this is 3 inches, and this is 4 inches. Like, they're all different in sizes. But for some reason, they mark a couple walls. That means these 2 walls are the same size, whatever they are. Even though you don't know the measurements of them, they're the same, because of that little marker. Okay. They could have double markers on different walls. Maybe it's something like this. Fine. If they have a double marker, these walls are the same. They may not even look like it, but the markers tell you that they are. So that means what's the length of this wall on the top? 4 inches. You can transfer that 4 up. That's the little congruency symbol on a picture. That was something we didn't get to talk about yesterday. It was something I wanted to go into today. You just need to see that. Because some people will start looking at the book like, what are these things? They're marking everything on the picture. It means they're equal, they're the same size. Okay, we're good with congruency. Okay, perfect. Now, let's talk about segment addition. Segment addition. Let's B, Y, in between A and C on a line segment. Then AB plus BC equals AC. AB plus BC equals AC. Unless you write that down, I know you've seen that for the first time, like, what is that even saying? That's what we'll get to. We'll talk about it. Sorry. what you're looking at here is one of the basic properties of geometry, that you're allowed to add segments together to make a bigger segment, a bigger stick. They're very specific in the way they wrote it, that B lies in between A and C on a single line segment. What do you know about line segments?
They're measurable.
Say it again?
They're measurable.
They're measurable. What else? Is that the same thing?
They're straight.
They're straight. Ooh, big. Both of you nailed it. Okay, good for you guys. Okay, they're measurable and they're straight. There's no curves to it. So if we're putting a line segment on the board and B lies somewhere in between, so here's B, somewhere in between A and C. I didn't know where. It's not the perfect middle. It didn't say that. It's somewhere in between on a line segment. So the line segment has to be straight and it has to be measurable. You guys nailed it. That was awesome. All right, now we're going to be adding pieces together. So if I were to measure, so this one right here is talking about the measurements. So if I were to measure how long AB is, this stick right here, it's got some length to it, whatever it is. And I were to measure BC, this one right here, that's also got some measurement to it. It would have to equal AC. Now notice, I use an equal sign, because I'm actually talking about the numbers. That's why I left the bars off. The measurements, so whatever these are. So if this was 4 inches, and this was 7 inches, then how long is this whole stick?
11.
It's 11. You're allowed to add them together. Now, it should be common sense. Most people are like, well, duh. Or it's kind of straightforward. I understand that. Yeah, but you would not believe how many people will get it wrong later when it gets more challenging on the type of problem they're going to give you. You're allowed to add the two small pieces together, and it makes the whole thing because it's straight and it's measurable. That's the big deal. Now, the pictures themselves, the sticks can be added together, and whatever these two sticks are, the pictures themselves, they should be congruent to the entire stick from A to C, the whole thing, from beginning to end. But you're seeing the math that's involved, and you're thinking, okay, Ward, how does this get any more difficult? Well, here's how. I'm going to give you the first one. I'm going to pull a problem right out of your book. Here's the first one. This is just a little more difficult than that 4 and the 7 idea. Okay. AB is 11. BC is 4x. And AC is 83. Find X and BC. Okay, this is our first problem. This is what the book would give you. They'd give you a mock picture up above, hopefully. And this might be, the example that's in the book. So this would be the example that you have. That's problem number 10 in your book. I have no idea. What they want you to do is use the math you just figured out and solve for the missing letter. So AB is 11, so I'm going to label it. Here's 11. BC, B to C is a 4x. And what do you get when you add them all together? What's the whole stick, A to C?
83.
83. So 4x plus the 11 equals the 83. You're allowed to add the two pieces together, and that equals the whole stick. It's algebra 1 problem now. You'll subtract the 11 across, because remember, when you solve algebra, you're doing the order of operations backwards. Order of operations, PEMDAS. Please excuse my dear Aunt Sally, whatever they say in elementary school, right? We're going SADMEP, okay? So SADMEP is when you solve equations for a variable. You add and subtract first, whatever order comes first. Well, I'm going to subtract the 11, that's 72. And then you multiply and divide last. Okay, if you had exponents and parentheses, you do those last, but I would divide by 4. So 72 divided by 4, that is a 1, that's a 318. Like that. Okay. All right, now, we found x, right? Check. Boom, done. X is 18. figured it out. That seems common sense once you first see it. But are we done yet?
No.
Yeah. We didn't answer the final question. It wanted to know how long that stick is. 4x stick. There's a common sense way to do it. You need to solve for x to figure it out, but you can plug it back in. We know x is 18. Plug the 18 back in. 4 times 18, guess what? It's 72. So BC is 72. How I also know that is common sense. If the whole stick is 83 and this one's 11, that means this one has to be 72. That's the only part left that would add with 11. You already had it, 4x, the stick 4x was 72. They said it earlier in the problem. You would not believe how many people will get those wrong. They just don't understand what to do. You have to do segment addition. Add the two small sticks together, make a big stick. All right, I'm gonna put a problem on the board. I wanna see if you can do it now, by yourself. Same stuff, I'm gonna leave that on the board. Put that one there. I wanna see if you can do this next one by yourself. See if you can piece all this stuff together. Here we go. Same exact structure. All right. For the variable. X and Z. YZ, say 6A plus 2. XZ is a 5A plus 22. And then XY is a 3A minus 4. Throwing in the deep end real quick. That's all you get. You get that instruction, you get the problem down below, you have to solve for the variable and YZ. Yep.
Like, so for XZ, wouldn't that be like the top of it?
Yep. Yep. So solve for the variable. I'll give you, 5 minutes. And yes, you can move around, you can talk with your neighbors if you need to. I'll give you 5 minutes here. And let's try. Don't feel bad if you're like, "Oh, I don't know how to do this. I don't know what we're doing here." Look at my other example, try and do the same thing. See if you can piece this together. didn't give you quite 5 minutes here. Only a few minutes. Let's talk about it. What's the important thing when you read the instructions, though?
Make sure you understand them completely.
Okay, so what is the instruction telling you that's important in the very beginning?
To find the value of the variable and y is z.
Yeah, you have 2 things to find. It's the same problem that you did last time. So if you look over there at my other problem, you have to find the variable, so that'd be my letter A, in my case, and the other stick, the stick y to z. So at some point, you're gonna have to plug in your A into yz, whatever it is. Okay, now that's important, super important, you get that. You have to find 2 things on this one. I know it's subtle, but you have to find 2 things. Now, the drawing, do you agree? I didn't give you a drawing. You had to figure it out from what they're saying. They're saying that y is in between x and z. That means when you're doing this problem, you better draw a mock picture like this. X, y, and z. No, doesn't matter where y is. Yeah, not at all, right? Because it didn't tell you, it's not in the middle, it's just somewhere in between them. Okay, my drawing might be way off, it doesn't matter. Details. But why I'm drawing this? Because if you don't draw it, how do you know how to label it? Where the things go, which ones to add? Because I might have put them out of order. Because if you look at this, look at the part I gave you first, yz. That's a 6a plus 2. That's yz. The xz is the whole stick. It's the big stick. That's the 5a plus 22. That's the big stick. And then the last one was xy, that's the 3a minus 4. I put them out of order to see if you're to draw it, do you know which ones you're supposed to add? It's not always just having the top 2 equals the third one. No. You have to make sure you label the picture that you've drawn so you know which one's added. Which ones am I adding now? Which ones do I have to add together?
X, Y, and Y, Z.
Yeah, these 2. These 2 things. And that should equal the top one, because it's a segment. Segments have to be equal to each other. So, let's do the math here. So we have to add these 2. So 3a minus 4 plus the 6a plus 2, and you better equal the big stick 5a plus 22. Okay, that's number 1 thing people get wrong right in the beginning. Oh man, I had the wrong things. It happens. You gotta draw a picture, label a picture. I label everything. If that was my problem in the homework, because I do your homework as well, I label and I draw the picture in my homework, and then I do it from there exactly how you guys would. Even though the book said all that stuff, this is what you're seeing in my homework when I do it just like you guys do. I'm actually drawing a picture, labeling it, figuring out which parts to add together. It's a segment addition. Now to solve, let's add some like terms here. So on the left side, what do you get when you add some of these things together?
9A.
9a and -2. All right? Because 3a and 6a make 9a, and then the -4 and the 2 make -2. On the other side, I still have the 5a and the 22. All right. So now this is really testing your algebra 1 skills. I threw you in the deep end. You gotta have algebra to get in here. So to do this, now I'm gonna move the a's to one side, the numbers to the other. I'm very visual when I do my algebra. Like very, very visual. Like when I solve algebra 1, I literally think of like I'm moving numbers around. That's how I see it in my head. That I'm moving this 2 over here, and I'm moving the 5a over here. Like I'm very visual. Like I know people are like, oh, you just add to both sides or you subtract both sides, but I don't. I drag things around. I move the 5a across, so it's 9a, and when you drag it across an equal sign, it becomes the opposite. Anytime it goes across the equal sign, it always becomes the opposite of what you're doing. So if it was a positive 5a and I drag it across the equal sign, it becomes negative. If the 2 came across the equal sign, it becomes positive. That type of thing. So then I can solve. That's just how I see it. Some people don't do it that way. That's just the way I see it. Okay, then what are we getting? 4a and 24. Kind of nice. And what's my a? 6, because you have to divide. If you drag it across the equal sign, it has to do the opposite, so 24 divided by 4. Because dividing by 4 is the opposite of multiplying by 4. So you get 6. That's done. We found part A. Right, we found the variable. But, what's the last step? Yeah, plug it back into YZ. You have to plug it in here. Because that was the second part of the homework question. It said find the variable and YZ. So you have to take the 6 and plug it back in. 6 times 6 plus 2. You get 38. 36 plus 2. It's a lot of steps. Lots. Just from a simple problem, adding 6 together. Okay, seeing it for the first time, it's like, okay, that makes sense now. But if you never saw it, yeah, it's kind of tough. It's tough to go from algebra class to here because you're not used to trying to set up your own problems. You're used to seeing a problem in the book written like this, just written out, and then you solve it, right? That's kind of what algebra class is. Now you're in a class where you have to interpret what to do, draw a picture by yourself, figure out what parts add, how to set it up. It's a lot of interpreting, right? It's a lot of trial and error in here. And we're still solving, don't get me wrong. We are still solving sometimes for variables. You're still seeing the normal macular in algebra 1. But you have to get used to that. We're going to go further sometimes. We are going to go past that. Okay. Questions, comments about segment addition stuff? Okay. All right. What I'd like you to do right now, on your paper, I would like you to draw 2 line segments of different lengths. 2 line segments on somewhere in your notes. Let's label the first line segment. They don't even have to be attached. They can be, separate. 2 different line segments. One has to be longer than the other. They have to be different in size. Let's label one of them. Let's label it. I don't know. Let's go like MN. Let's not be too creative here. So one of your sticks better be MN. And then the other stick, I don't care if it's bigger or smaller, it doesn't really matter. Let's call this one PQ. All right, what we're gonna do today and tomorrow, we're gonna do it for the first one today, we're gonna measure your segment with a ruler. Now, I know this seems silly, it's like, Warren, okay, what are we doing this for? Because some people don't know how to use a ruler yet, okay? Now, I'm going to give you one of my rulers. Don't draw on them. Don't tear the metal thing out. These are brand new. Like I literally just bought them. We're going to measure your thing. We're going to use the inches. Okay. So, brand new. Don't damage them. All right. We're going to measure one of your sticks. Now, I want you to have the side with the inches on it. Face up. Inches, face up. Now, here's the big thing with the inches side. There's a lot of markers. On these, if you count all the markers from like the 0-inch marker up to 1, I believe there's 16. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, yes. So, there should be 16 marks. Now, how a ruler works. You're going to place your ruler down. I know it's going to seem a little silly. We're going to do it for your first marker. And then we're going to measure the MN stick. You need to line up where the 0 mark is. And it says like the word inch in here. You would not believe how many people are not comfortable measuring yet. They just don't see it a lot. You never had to really, really do it yet because maybe you didn't take drafting or you haven't taken any shop classes or anything that requires intensive measuring like a textiles class. You have to be super precise in textiles. So, or I guess art class too. But we're going to be measuring. So you got to line up 0 right at this marker. So line it up perfectly. Like mine, I got a little gap. I got to finish it. It doesn't go to the end. It starts at the first marker. Then you're going to count up and you're going to figure out where it ends. I have no idea. If it went right to the number 1, fine, it's 1 inch. If it didn't, now you have to figure out what marker you're at. And that's the tricky part with how inches work. You have to see the markers. I'm going to try to show you the best way I can so that you know how to actually measure with inches. And this is my little shortcut for you. I know that I have a couple minutes left here. The half is the big stick in the middle. Why it's half? It's the first big line out of the two big lines. The first one out of the two big ones. That's the big one, that's the big one. That's the half, okay? The next marker, the next big ones. This is the fourth marker and 3/4 marker. This is the first out of 4 big markers. 1, 2, 3, 4 big markers. The top numbers, if you notice on fractions, the top numbers are always odd numbers. The bottom numbers are always evens. That's how it's working. So yes, this is 1 out of 4, this is 2 out of 4, this is 3 out of 4, this is 4 out of 4. The next markers are 8s. 1 out of 8, 3 out of 8, 5 out of 8, and 7 out of 8. So first marker out of 8 markers going across, the big markers. Then this would be second out of 8, third out of 8, 4 out of 8, 5 out of 8, 6 out of 8, 7 out of 8. And then the other markers are 16ths. 1/16, 3/16, 5/16, 7, 9, 11, 13, 15, and 16 out of 16. That's just how inches work. It's the easiest thing in the world. Once you see it for the first time, or you just see somebody explain that to you, like it's always, the top numbers are always odds, the bottom numbers are always evens, and you're just counting like the big markers, it's pretty straightforward. So just knowing that it's odd numbers, 1, 3, 5, 7. It's super easy to figure out. Now if it's in between, because if you're looking at your ruler, inches are not that exact. There's a lot of gap between these markers. So you gotta be kind of close. If you go to the centimeter side, the metric side, not the customary side, but the metric side, they're way closer together. The metric system is more accurate than US customary. US is the inches thing, it's not as accurate as metric system. I don't know why we don't use metrics. But I want you to measure it right now. You got about 30 seconds, I'm gonna collect your rulers here. So I'll give you rulers again tomorrow. We are gonna measure these, because we have to be able to measure stuff in geometry class. I'm not joking, we are gonna be measuring a lot of stuff. We're doing lots of projects where your numbers have to be accurate. Okay, homework is due tomorrow, do not forget. Get it done.